Hello class. Today we're going to look at version control. And then in class we'll talk about the project again, and then we're going to look at using get for version control. So let's take a look at this scenario. You're a developer writing and testing programs. Your programs are part of a larger application development project, and other developers are working on this application with you. So where do you or I store my code? Now we could try and use just a normal directory, simple file structure to save it. But you can see that kind of turns into a mess here. We have the repo name with a date, as it changes over the date, and just random tags. So what exactly has changed in each version? We'd have to do diffs on every file to find out. And what do these changes mean? Did anyone document or comment them? Why do we store the whole project instead of just the modifications? This can save us a tremendous amount of space. And how do we keep variants of the project in sync while it moves on? So the main problems with this mode are losing the history. Someone else can overlay your code. What if you get your bugs, what if I get your bugs in my code? My code was working, now it's broken. What happened? I fixed this last week, but the change isn't in there anymore. And what if two of us change the same file at the same time? What happens? So the issue here is that we all want our private workspace to work on and be productive, and that is what you need. But having your own private workspace comes with this challenge. Directory structures were attempted at one time, but VCS quickly showed up to solve this problem. So here's a little graph of essentially how the lines of communication grows exponentially as you increase your team. Again, leading to a lot of difficulty whenever trying to develop code and keep it in sync with it itself. The function for this, in case you're wondering, is n times n minus 1 over 2. And here's the reasons that we want a repository. This coordinates across multiple developers on a team. It keeps history. It allows me to revert back to the prior version of my code, allows me and others to work on the same module at the same time, tracks who is working on what. It'll prevent us from clobbering each other's updates, describes each version of each module, allows checkout, check-in, allows merge management, can track changes and compare one version to another, provides a log of all changes, and also allows me to add, delete, and change and rename code. All of the previous features are provided by VCS or version control systems. There are two designs for version control: central repository or distributed repository, otherwise known as VCS and DVCS. So here is the diagram of a central repository system. Note that there isn't a local repository. While they will have a local version of the code, the commits or saves go straight to the central repo. With a distributed repository, we can see that there are local repositories that a user can commit or save to, and then push all those commits to the central repository. Also note that a distributed repo doesn't mean there isn't a central repository. It doesn't mean there has to be either. So we'll get to, I think there's a diagram of this a little later. So why DVCS? It's cheap, fast local branches. They can be worked offline, created offline, but it has full local branches with their history as well. It keeps a history of changes, pulls, pushes, commits, and merges that you can sort through and figure out what changed. Has offline commits, and each working copy is a full backup of the repo at some point in time. So command line versus GUI. Command line has the full range of commands, whereas many GUIs are limited to the basics. The GUI can be more intuitive and gives a great representation of the history of the repo. I'm going to teach you guys command lines first, and then I'm going to actually show you a GUI, Get Kraken. You get it for free with the software development pack, but it's really awesome. Here are some other popular source VCS central repos, central repository VCS tools. We have the current version system, CVSNT, OpenCVS, Subversion, and Vesta. Subversion is probably the most popular one out of this. There's another one called Perforce, and I actually use that at Lockheed. And then we have some popular open source DVCS tools, and these are distributor repos. So we have Git and Mercurial being the most popular, and then a whole lot of other ones. And you can check out more about those on these two links. I've got the GUI there as well, or Get Kraken. So here's a history of it. Like I said, as computers became distributed and software really started to pick up, you can see they saw this problem early on. All the way back in 1972, they started trying to figure this out. In 2005, we had Git, Mercurial, and Bazaar. And these are all, this is the trend that the industry has moved to over the last few years, is towards DVCS. So again, we have local operation, individual user. The client server model is based more on the centralized repo. They started with the loco or lock on checkout. And so you can see here, limited team size, connected operation. You have to lock whenever you make a change. And then distributed, the disconnected operation, scalable team size, and branch based. So we'll hit a little more terminology. We have repository, which is the version control collection of files and code. It's not just a directory, but it's actually a directory with metadata that keeps track of the history. We have a commit, which is a write or saves changes to that repository. We have a revision, specific version of the repo or file. We have a tag, which is a logically named and labeled revision. So revision is more of just every commit. So you can go back to any commit that you've made, and that will be some revision of the code. But a tag is actually like a version. So a lot of times people tag their releases, and so that you can jump back to a logical release. So then we have the branch is a linear subset of changes within the repo. A merge is used to combine discrete branches. So if we have a master branch and then a working branch, you can push the working branch into the master branch, or merge the working branch into the master branch. And then lastly, we have diff, and that's the set of changes between two revisions. So here we can look at a version control history tree. This is much like what Git looks like. So we have our initial commit, and then someone that we'll call the blue line master can continue to work along master, while the branched, the purple circles, can add a bug, fix a bug, or add a feature that wasn't in there, and then eventually merge it back into the master branch. And again, just any random commit is a revision. So all of these are revisions along the master branch, the ones on the blue line. But then we can tag it as version 1.0, and that's actually going to be our release version. And then again, with the blue, you can see that they branched off another branch. So lock on checkout, this is one of the old styles that they used for whenever people were editing to keep two developers from editing the same file. Developer 1 checks out a file for editing. The repository puts a lock on that file, and other developers can't check out the file until developer 1 performs a check-in. Then we have merge on modify. The developer 1 gets the latest version of the repository. No locks are placed on any files. Other developers may edit the file. Changes committed back to the repository are merged with the current repository. So Whenever these get pushed back in, you can have merge conflicts. DVCS is merge on modify, Git is merge on modify, and we'll look at merge conflicts a little more. So here's a comparison method between loco and mom. We have locks files for editing, no concurrent file access, check-in replaces current revision or current version, no conflict on check-in, that's nice, works with any file type, central repository model. Merge on modify does not lock files for editing, allows concurrent file access, changes are merged with the current version, possible conflict when committing, and this is a big one, the possible conflict with committing. If you and another developer edit the same line or even the same file and all the changes are close enough, you can wind up with merge conflicts. Works best with text-based files, central or decentralized repository supported. So a merge conflict occurs when two developers edit the same lines of code. This is generally sorted out through discussion and can be done using merge conflict tools. It does require manual intervention. So merge tools, text-based or GUI-based, often the same tool as a diff. These will offer line-by-line comparisons and allows the user to choose which lines to keep. Once completed, mark as resolved and commit. So this is what a merge example might look like. So you can see on the left we have theirs, on the right we have mine, and then below we have a merged version. And so you can accept either one of these versions or the merged version. So best practices when using version control is to commit early and commit often, use clear commit messages, communicate when resolving merge conflicts, only commit related changes in one commit, one topic per branch, and only commit source code. The things you don't want to do is commit compiled files, commit secure info, credentials or passwords, merge broken code, don't break master, never break master, and combine multiple topics per commit branch. Alright, now that we've talked about version control, let's focus on Git. Here is a local project. This is just a directory that's on your computer with code in it. And here you can see after we run the git init command, which I'll talk to you about a little bit later, we get metadata for the local repository. And this actually is attached to that directory. You won't see a difference on your computer. In the directory, you're in the repository. But it adds a lot of metadata that helps us track all the changes. Another way to get a local repository is to clone that repository. An existing repository exists on a remote server, a repository exists on a remote server and is already under version control, and then you can clone this repository and download it to your machine. So which changes should be part of the next commit? Generally it is only files that are modified, here marked with M, or files that are added, but that's it. If a file has not been changed, it is not committed into the save branch, or into the commit. So only staged changes are saved in the local repository as a new commit. So this is handy too because you can exclude binary files. So if you compile your C++ code or something along those lines, we can exclude binaries and only commit the source code even while we have binaries sitting there. Alright, so let's take a look at some of the git commands. Starting a new git repository. First, let's assume you have a file system containing project code modules. Navigate to that directory and run git init, which creates your local repo. So here you can see the steps. So they make a directory, then we see the end of that directory, and now we just do an ls-tech-l, nothing in there. Then we run, after making a file, handle form.php.text, we run a git init, and you can see initialized empty git repository, and there you go. And now you can see at the bottom we have the .git That's actually where the metadata is stored. So now that I have a local repo, what can I do? Well, you can identify yourself. This is with get config, so we can see here the second two steps: get config global username Alan, get config global username Alan Paradise. This is where you actually set up your username into Git, so that you don't have to type it in every time. We can check the status. So here we run the status, and we see we have the initial commit. This is telling you that you have untracked files. So the file in red is not tracked by Git, and so you'll have to run a git add to actually track that file. So working copy, a tracked or unmodified. So these are your project files: tracked, modified, and untracked. So the only things that would go through to the staging area when running a commit is the tracked and modified. So here we get a git add handle form.php.text, and then run a get status, and now we can see that it's in green, and this is changes that will be committed. So again, we see that our modified file has been added into staged. In this case, it would be basically a newly tracked file. And then we have in the local repo committed. And the way you do that, it isn't actually in two steps. It's not working copy and then staging area and the local. It's basically you're sitting in working copy, you've changed it, and when you run get commit, the staging area is just anything that has been modified. So again, right here, the only file in the staging area is handleform.php. So here you can see get commit tag M for message, and then use a data form handler, and it's telling you one file change, 94 insertions, because it created the file and it has all the insertions of all the lines. Running get status will check the local repo against what is saved in the history and what is actually inside the directory. So if you modify another file and run get status, you'll see that there's a file modified. But here we can see that the working tree is clean, and that is because we have no changes. So we can use get diff, and this will compares two versions of a file, modified versus last committed. It'll show us chunks, basically the insertion chunks or the removed chunk or the deleted chunks, lines added or removed. Okay, so here we can see the different hunks that we're given, or chunks. That's this whole section here, and then the modified lines. I have another section here, or chunk with modified lines, and another chunk with modified lines. Okay, this is the starting line number of the old file. So notice old file is plus or minus, and new file is plus plus. That has to do with this top line right here. Okay, because these plus and minuses with the green and red meaning inserted and deleted. This is actually a modified line right here. So you can see class Twitter paragraph, that's what was there before. Now we changed it. So this is what a change will look like. This is what it used to look like. This is what it looks like now. So we start line 4 to 6 in the old file, 4 to 8 in the new file. Sorry, not 2, 8. 4 and then 8 lines in the new file, 4 and then 6 lines in the old file. Makes sense, we added 2 lines. Subtracted 2 lines, so now on line 12, the following 8 lines, on line 14, the following 6 lines, and so on and so forth. But you won't really use this get diff as much. It is nice just to get a quick overview of what's going on, but you can use it using a GUI tool for your diffs is much, much better. And again, I'll show you one of those guys in the demo tomorrow. So now we got get log and get log stat. So here's the output to get log. Basically gives us the commit or revision number, which is this hash right here. Again, revisions are just like all the commits. They're different points of the code you can go back to, but they're not like specific to like a version or something. That's tags. Okay, tells us who the author is, and it gives us the message, and then on the date that it happened. And this is the commit message that we're seeing here. All right, here we did get log stats, and now you can see what files were edited, how many insertions, how many deletions. This is pretty good just to get an overview of what changes occurred. All right, let's take a look at branches. So here is what a branch structure can look like. Starting at commit 1, we can branch off for a new design and do a commit here for any new code that we add. But while on master continues, and the commits are all sequentially ordered, so you can see on master we actually do commit 3. Now the person who did the commit just ran the commit with a tac m, but it will be the third commit of this project. Okay, and then someone branches off for a bug fix, we get commit 4, and then along master commit 5, over here on the new design commit 6, and so on. Okay, so at any time only one branch is active or checked out in Git, and that means that the head is on that branch. So if this is my master branch and I branch off to a branch called contact form, whenever I say get checkout contact form, it will actually take me to that branch and move the head onto that branch. And so now that's where I'll be developing. And at any point I can say get checkout master and immediately be in master with all of its changes. So again, here you can see we can get checkout master, and that will actually move me from here to here. I haven't moved directories or anything, but it actually allows me to see different versions of the code along the branches. So what a merge does is that will integrate a branch. Okay, so we have commit 1, 2, 3, and then someone was working along the master branch, commit 4, maybe a bug fix came in here, and then we want to merge our branch in because we're done with this. And we can finish it or continue development, but we're done with one revision that needs to go in. And so we merge this branch into the master branch, and master continues, and we'll actually then move us into master branch as well. That's why head gets moved over here. But the merge will allow us to bring all the code that's over here and any changes that we have and merge those into master. And you can see the handiness of this is that master is just one continual historical line that is constantly getting new code added to it from this branching method. So here's some links to some videos to go over Git, but again we're going to hit it pretty hard in lecture tomorrow.